Hey, everybody, and welcome to another episode of JavaScript Jabber. This week on our panel, we have Steve Edwards.
Hello from Portland.
AJ O'Neill.
Yo, coming at you live from frigid Provo.
I'm Charles Max Wood from devchat.tv, and this week we're going to be talking about some Node stuff. And AJ, you kind of brought this up with some of the security stuff they're putting into Node, and I thought that might be an interesting place to start, and then we can dive into Node 13, which was released today as we record this. Yeah, it should be interesting just to see, where we end up, I guess, with Node and changes and all that stuff.
All right.
This episode is sponsored by Tidelift, the enterprise-ready open-source software managed for use solution. Tidelift provides commercial support and maintenance for the open-source dependencies you use to build your applications, backed by the project maintainers. Save time, reduce risk, and improve code health. The Tidelift subscription is managed open source for application development teams. It covers millions of open source projects across JavaScript, Python, Java, PHP, Ruby, .NET, and more. Your subscription includes security updates from Tidelift Security Response Team that coordinates patches for new breaking security vulnerabilities and alerts immediately through a private channel so your software supply chain is always secure. Tidelift also verifies license information to enable easy policy enforcement and adds intellectual property indemnification to cover creators and users in case something goes wrong. You always have a 100% up-to-date bill of materials for your dependencies to share with your legal team, customers, and partners. Tidelift ensures the software you rely on keeps working as long as you need it to work. Your managed dependencies are actively maintained, and we recruit additional maintainers when required. Tidelift helps you choose the best open source packages from the start, and then guides you through the updates to stay on the best releases as new issues arise. Take a seat at the table with the creators behind the software you use. Tidelift's participating maintainers earn more income as their software is used by more subscribers, so they're interested in knowing what you need. Tidelift supports GitHub, GitLab, Bitbucket, and more. They support every cloud platform and other development targets too. The bottom line is you get all the capabilities you expect and require from commercial software, but now from the key open source software you depend on. Check them out at devchat.tv/Tidelift.
Well, let me give you some background on what I'm doing. I've been on the show as a guest before to talk about this. So Let's Encrypt. I maintain a client called Greenlock, which is kind of the premier Node client for Let's Encrypt. And Let's Encrypt, for those that are unaware, is how you get free SSL certificates. So it's a joint venture, not really venture per se, but a collaboration between the Electronic Frontier Foundation, Mozilla, and a number of sponsors. They have their own root certificate. And for those that don't know, certificate signing, you pay $10 or $300 or whatever. There's no actual real cost in a certificate except for when it's validated. So if they have to call you up on the phone or you have to fax in, like if you do extended validation, which that you're more likely to need for a code signing certificate for, say, Windows applications or Mac applications that you want to get into a store, not something you really need for a website. So the actual real cost of SSL certificates is basically nothing. And so Mozilla and the Electronic Frontier Foundation got together, and there's kind of a buy-in process. If you want to be a certificate authority, you have to buy into it. There's another organization, ISRG, I think is what it is, Internet Security Research Group. They're another part of this collaborative effort. So they all got together and just put up a server that will perform a series of validations via either an HTTP call or via checking a DNS record, or even some fancy stuff down at the layer in between TLS and the HTTPS or other application that sits on top of it, a layer that's called ALPN, or Application Protocol, something identifier. And basically it says whether you're using HTTP 1 or HTTP 2, or if there's another protocol that you're using. So that's kind of the broad scope of what I'm working in and what brings me to the types of uninteresting and boring things that I come to. So before I go further on that.
Yeah, well, and I just wanted to throw in, I've been using Let's Encrypt for a while now. I've moved completely off of the paid for SSL certificates just because it's free, and I just set up the Let's Encrypt and then set up a cron job and it's done. And there are actually scripts that'll just do it for you now. So I think Greenlock is one of them, I believe.
Yeah, so Greenlock has a couple of different components. It has a command line tool. It has an actual web server that you can integrate with Express, and it has a library. So whether you're building, and the primary focus of Greenlock and what I built it for is more in the IoT space. However, the greatest adoption in terms of like per certificates issued has been from small web hosting companies. But I've created it for IoT and enterprise on-prem because that's the need that I had with the home server that I've been working on is, in that space. It also works great for local development. If you want to get a certificate, instead of having self-signed certificates on localhost, you can get a local.mydomain.com and get a certificate on that through it. Those are some of the use cases that it fits in well. So Let's Encrypt recently made a change. For some reason, they didn't change their API number from V2 to V3, even though it was a breaking change. But they decided that it was small enough and it'd be easy enough to fix. They didn't need to do that. Well, now it's almost November, and the change was supposed to go live November 1st. And it actually still does in the staging environment, but they are not requiring, they're giving it a year before they require it in the production environment, which is like, a lot of, it's hard when you're working against a deadline of something that's going to break and, you built it 6 months ago. Well, 6 months ago was the last time you did significant work in it and you realize, you need to do more stuff. Anyway, so I did an Indiegogo campaign that was actually quite successful from the people that have been using it to gather funds to be able to work on it full-time for a couple of weeks to basically dig out all the crufty code because it's supported, I think, as far back as Node 6, maybe even the current version might even work on Node 4, but it's kind of time to get rid of a lot of that legacy cruft, just code that accumulates in the code base as you work on something over, a couple of years, and you're trying to keep backwards compatibility, and then trying to keep backwards compatibility leads to bugs that you fix it one way, you lose, you fix it the other way, you lose, you're just stuck with like, crap, now there's an edge case either way that I fix it or I don't fix it, I still, going to encounter a problem. So I was able to take the opportunity to go through the code base, and I did a couple of cool things. I made it so that there's a browser version and the Node version are not different. So you can now build it with Webpack. It has very few dependencies. It's entirely Node and browser specific code where it needs to be in a way that, like I said, you can build it. And it's not going to include like Node's crypto library. If you're building it with Webpack for the browser, it's going to stay small. The thing is, it's like under 80 kilobytes, everything. Like it does PIM parsing, ASN1, X509, like all this technical stuff, very small. And as I was in that process of cleaning up, I had a bunch of comments in my code that were like, workaround for issue X and see this GitHub issue. And so I went back and checked out on some old issues and found out some things that I think are really cool about some of the updates that Node has had in their TLS stack recently. One of the changes is, and this is all like, it's highly technical stuff. So please interrupt me, ask me, what the heck I'm talking about, because otherwise I'll just ramble and I won't know that you don't know what I'm saying, because this stuff is so familiar to me from working in it for the past couple of years. But Node has a TLS module, and TLS is the actual real name of SSL. SSL was deprecated like a decade ago. No one uses SSL. It's been off the shelf for a very, very long time. But we all call it SSL still because it's just one of those things. We call it SSL even though it's actually TLS. So TLS is a handshake that happens between a client and a server, or it could be peers actually, that they exchange certificates, generate some random numbers, and say, we're going to use these for encryption. And if you wanted to learn about that, you can look at Khan Academy has some videos on Diffie-Hellman and the history of cryptography that are really helpful. TLS is that layer that handles the encryption. So it sits above the net module and it sits below the HTTPS module and the HTTP2 module. And One of the things that has changed in the past couple of years in Firefox in particular, and I believe other browsers are beginning to adopt this as well, like Google, the whole move to HTTP2 has been about fixing basically legacy bugs or lack of features in TLS that are legacy from the SSL days. And when you go to connect to a website, there's more handshakes taking place than need to. And this has been one of the critical reasons that people have claimed, like, oh, we're not going to use SSL on our website because it's too slow. Because the initial latency of establishing a TCP connection was a little bit longer than it needed to be. It wasn't extreme by any means, but some people felt that they were at such a scale that they shouldn't do that. And Google wanted to combat this. And so they found that you could basically shortchange some of the handshake, but then it would fail on 1% of servers, and that wasn't good because you can't have 1 out of 100 requests not work. That's like a terrible, horrible ratio. So Google made some changes to the standard, which resulted in basically HTTP2, which integrates the TLS layer and the HTTP layer more closely together so that there's fewer handshakes. It's very, very concise, and it sends all the information that the server needs to respond to the client and to establish a connection all at once, basically assuming the happy path rather than saying like, hey, are you there? Yeah, I'm there. Hey, can you do this? Yeah, I can do this. Hey, can we agree on this? Yeah, we can agree on this. It's like, hey, I'm here. This is what I would like to agree on. This is what I can do. Can you do it?
So AJ, the difference between TLS and HTTPS, I know you said there are two different parts of the stack, one's on top of the other. So is TLS basically say, hey, let's make sure that we're agreeing on everything and we have a secure channel here, and then HTTPS is actually just transmitting the requested data?
Yeah. So HTTPS is literally not a standard. HTTPS is you connect on port 443 and you send a TLS hello packet. And then you get back a TLS response. And there's a handshake basically like what I said. It says hello. And then the other one says hi back. And then it says, this is what I support. And the other one says, this is what I support. And this one says, here's my key exchange. And the other one says, here's my key exchange. And TLS 1.2 and above, and actually 1.3 I think is where it was standardized. 1.2 you could do it, but some servers didn't recognize it. Anything that supports TLS 1.3, basically it says, hello, this is what I support, and this is the key that I'd like to exchange. And then the server responds back in kind. So it takes down basically 3 handshakes to 1. And HTTPS is just HTTP. So an HTTPS server has no knowledge that TLS is going on. In Node, the only reason that you could tell that you have an HTTPS server or an HTTP server is on the request object. You get request, response, next is kind of the way Express does it. So you have request.socket.encrypted. And that's the only thing that tells you whether you're on an HTTPS server or an HTTP server, because other than that, it's literally just an abstraction layer as far as HTTP is concerned. That's not true with HTTP2. Well, not entirely anyway.
And so the difference with HTTP2 is it's more baked in then?
Yes. In the HTTP2, both encryption and compression are part of the specification.
So you just get it automatically if you're using HTTP2?
Yes. And there are ways to run it in a degraded mode, but that's more an experimental feature than it's not intended to be used that way. It's just kind of, I think, something that was put in there as a way to help debug.
So that's why HTTP2 is supposed to be faster, because you're doing more with fewer handshakes and fewer back and forth, or less back and forth.
So on the TLS 1.2 versus 1.3, that's the case. But in terms of HTTP2, some of the advantages are that you could build heuristic-based web servers. So an example of that would be, say you get a request from a website on your server, and it requests 4 JavaScript files. And if you're not using a CDN, then you can actually get the performance benefits of what HTTP2 could offer. So an HTTP2 server that is not just a dumb server, like most of us in the Node world we're familiar with kind of the express style of server where it's just a dumb static file server, and that works great. And that doesn't get, it gets a little bit of the handshaking benefit of HTTP2 coupled with TLS and compression, where they're all kind of together in a package deal rather than the web server deciding individually, does this file get compressed? Does that file get compressed? There's a more streamlined compression. But what's actually happening with HTTP2 is you can have a stream. So if you get requests that say, oh, I need these 4 files, and let's say it's something like, you're serving up different files to Internet Explorer than you are to Firefox because Internet Explorer is missing, or Edge is missing an API that Firefox has. And nowadays, it's just as likely to go the reverse as well. That Edge has been more focused on gaming and those types of performance APIs. Firefox has been more focused on advancing the web standards. Chrome has just been doing whatever they want to do. So you actually end up with browsers that have varying degrees of compatibility. You might have something where you lazy load some polyfills. If your HTTP2 web server is a smart HTTP2 web server, which there aren't many of these that exist, but I've heard of them, then what it will do is say, oh, you look like this kind of browser from my experience in dealing with different requests. I'm going to go ahead and send you these files, even though you haven't requested them yet, because I'm very confident that you're going to request them. So a smart HTTP2 server can heuristically determine what files to send to a client based on behavior and characteristics without the client actually having to request them. And I think that's one of the, probably only Google and a few others are actually doing that at scale, but it's one of the cool things about HTTP2 that you can implement.
Yeah, I could see them being able to do that just because that's a lot of data to store, isn't it? Remembering what I dealt to this type of client last time.
Mm-hmm.
I mean, if you look at it in terms of the happy path, your 95% is going to be 3 or 4 different use cases. And then your last 5% is going to spread out into a million use cases. And so it kind of becomes, again, the story of people that are on UC browser, AKA Android browser, just have a sucky experience because they're only like 3% of people. And, it's not necessarily a sucky experience, but if you had limited resources, you would be limited in how many different varieties of browsers. Actually, with 3%, that's probably large enough. It could fit into your heuristic or whatever. But anyway, it's more a theoretical idea than something that's put into practice a lot. But I am absolutely positive that Google puts it into practice because they're the ones that built the standard, and they knew that, they serve things billions of pages. They wanted to, make things as optimized as they could. So I have no doubt. I don't have an official statement from Google saying they do this, but they built the spec, and the spec is designed to be able to handle this use case. So I'm certain that they do it, and I would imagine many other large cloud providers have customized web servers that can handle that use case as well.
So we've kind of gone away a little bit from Node, right? So is Node building a lot of these features in then, making them first class, standard library edition kinds of things, or?
Yes. So as I was going through doing this refactor and removing cruft and checking issues and updates, what I found was that there are 3 important things that have been added to Node that didn't exist before. And all of that is really important context to understand why these things are important, because otherwise it's just like, whatever. So one thing that they've added is set context is now on the TLS object. In the olden days, the olden days, in order to start an HTTPS server or any type of TLS connection with Node, you had to provide a certificate on startup. Now, with something like Let's Encrypt, that doesn't make sense because you have to start the server in order to get the certificate. I mean, you can do it in other ways, but typically you start the server, then HTTP becomes available, which is one of the challenge methods. The Let's Encrypt server does a handshake with your server, and then you get the certificate. Or, likely you already have it in cache, but if your server is starting up for the first time and it doesn't have the certificates yet, then when it starts up, it's going to go fetch the certificate. Or if it starts up and realizes, oh, this certificate is now expired, it needs to go fetch it. So later, they added the capability, since this server name indication, which is basically virtual hosting at the TLS level, where it says, hey, this is the name of the server, get me the certificate for this that matches this server, and it comes back with the correct certificate, rather than what would happen in IE6, where it would just end up with a big red not secure page because it doesn't know what certificate to ask for. So this certificate name indicator tells the server what certificate to get, and Node has had this built in for a very, very, very long time. There was one point at which it was a synchronous API, and then that was obviously a bad idea. So they switched to an asynchronous API with a callback, and it's called SNI callback is the name of the API. And so you can say, when I get a request for a certificate, I'm going to go look up in my database what certificate I need to present. And now with the set context method being available, it means that we actually can let the server load up, let it renew certificates if it needs to, or get new certificates. And then the server can set the default certificate that would be presented to Internet Explorer 6 or certain types of IoT devices or older enterprise devices that still can use the benefit of TLS, but can't use the benefit of modern TLS 1.2, 1.3 with server name indication. So in those cases, you need this default server to be set. So having set context on the TLS object is something that has been sorely lacking until I think it was V 11.0.0 is when they introduced it, or maybe it was 11.2.
Mm-hmm.
And another API that they added that's also critical for, actually I started to say this earlier when I was talking about Firefox, and is utilizing a newer standard. Some parts of the encryption handshake have been de facto standard or loose and not well defined. One thing that's finally been put into a recommendation is that if you are connected to a server and the server manages multiple domains, like for example, example.com, www.example.com, exampleassets.com, exampleapi.com. It's very common when you go to a website that the certificate has multiple names on the certificate, and they're all names that you're going to interact with. So if you go to github.com, you're basically going to see what I just said. You're going to see like ghassets.com is going to be one of, if you look at the network tab, it's going to be one of the requests, and github.com is going to be one of the requests. You're going to see 3 or 4 domains based on what they're doing, which may point at the same server or may point at different servers for performance reasons, because of the way cookies work, because of lots of lower level details of how network efficiencies are made. They decide to host the content on different domains, but maybe the same server. So previously, the way that this was done is if you saw a different server name, you created a different TLS connection every time. So if I go to github.com and then the next request is to ghassets.com, if that happens to be the same server, I still have to make yet another network request just for that. And that has to hold that connection alive to be able to continue the communication with it. Well, this is really inefficient because you have all the handshakes that are going on previously before TLS 1.3, as well as you have this extra connection that could be pipelined with one of the other ones you already have that now has to be separate. Node added a get certificate method on the TLS object, which means now when a browser such as Firefox that actively does this and follows the candidate recommendation for how to handle multiple SSL certificates, when a browser connects to you in the TLS object, you have .server name. That tells you the original server that it connected with. So github.com, for example. With .get certificate, you can actually get the metadata about the rest of the certificate that includes the primary domain listed on the certificate, as well as all of the alt names or secondary domains that are listed on the certificate. So now, down at that layer, you can inspect and see, okay, I have server name is set to github.com, and the request in the HTTP header is coming in as ghassets.com. Well, as a stupid server, I don't know those two are related. That looks like a spoofing attack. So I would want to reject that connection because I would want to say, whoa, 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 whoa. You connected to me for TLS with github.com, but now on HTTP, you're requesting ghassets.com. This is spoofing. This is bad. I'm going to reject you. So for some of the stuff I was doing, Firefox was rejecting connections. And I was like, why is this? Because I was implementing domain fronting security. So I was preventing against this particular style of spoofing attack. And I had to do some rigmarole once I found out that the recommendation had changed from opening new connections to reusing connections when the same name exists on that certificate. I had to do some rigmarole to be able to figure out, kind of through a side channel workaround, what was listed on the certificate to be able to say, no, you're allowed through, you're a good client, but still reject the bad clients that are spoofing. Now with the get certificate method, I have that metadata about the number, the list of domains right there on the TLS object. So without having to do a bunch of workarounds, I can make the server more secure so that it rejects these spoofing attacks, but allows optimized requests that, otherwise would look similar to each other, now are easy to differentiate with just Node APIs.
So one thing that I'm looking at with some of this is that I've seen people put things into, or I guess committees, put things into, JavaScript through ES6, ES7, 2019, whatever, right? Pick a number. The bigger, the better. A lot of this stuff, it's either not implemented the way that I would like it to be implemented, or, there's some advantage to using a third-party library that does the same thing as the built-in library. Are you seeing some of this with some of these options in Node, or are they going to be more performant, more secure, et cetera, which is what I'm generally looking for if they're going to bake this in?
So this is stuff that the TLS module in Node has been an absolute mess and nightmare. It's something that isn't very often used because the use case is primarily more in IoT and less in web scale stuff. Mm-hmm. So these are APIs that have been long neglected, and you don't really want a third-party library if you don't have to have one. Like, it's something you do as a necessity. It's not something that you would want to do. There may be weird tricks you could do to make one thing slightly more performant, but some of the stuff was simply just not possible. Like, there was no way to do it, period. Like, the server would simply fail if you tried to handle the use case, or the workaround was cumbersome and rigmarole. So these APIs are very core additions to Node. They're not JavaScript, generic JavaScript related. They're related to the TLS context and TLS module in Node, and they're very nice to have. Node crypto is finally getting to the point where it's, dare I say, usable, which has not been the crypto modules in Node have been some of the worst modules because they're the least used. Most people are just using Node for Express and the HTTP module, and they don't mess with HTTPS or HTTP2 or with TLS itself. They're just dealing in that simple unencrypted layer, and they're not doing too much stuff with JWKs still. These APIs that are coming in are long overdue.
Now, when you say crypto, and you're talking specifically about web crypto with TLS and things like that, what about the other angles on crypto? So like AES or some of these other options that you have for, and I know that TLS uses some of these encryption schemes.
It does, yeah.
Are those getting better too? Or is it just kind of the overarching TLS implementation?
So one of the things that I mentioned a few times on previous episodes is that we now have key pair generation direct in Node. A couple of these things that I'm talking about, as far as I can tell, have been implemented directly as per my request, because I opened up an issue and said, hey, here's a potential vulnerability, or hey, here's a thing that's really cumbersome, or hey, here's a third-party module that everybody's been relying on that needs this niche feature for the past 5 years, and the maintainer just left, and Node v(x.x) broke the module, and it's not going to get fixed. Someone's going to fix it, but this same thing is going to happen again. Could we just get this in Node since you're already in OpenSSL anyway? Stuff like that. So this is actually one of the features that I don't know if I was the initial requester on or if I just joined in the conversation, But one of the things that I participated in and saw come to fruition and was just like super excited, and they've kept up with it and even gone above and beyond. So the generate key pair API in the crypto module is a godsend. The one thing that it's still missing that I'd love to see is better support for converting between PEM format, which is that base64 encoded file with the dashes that says begin private key, blah, 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 end private key, and dir format, which is literally just you get rid of those dashes and convert the base64 to a buffer. That's dir format. And then JWK. So it's actually really, really easy. It's something that only takes about 150, 200 lines of code to do if you're only implementing what you need. If you're not implementing the full ASN1 spec, if you're just looking at, all I need to do is go between JWK and PEM for these 3 or 4 formats, it's actually very small amounts of code that you have to write. But it's traditionally something that's handled by OpenSSL, and for whatever reason, that hasn't been exposed entirely. But it is fairly easy. If you generate a key, you can get the PEM version, and you can also take the Node native version and strip out what you need to create a JWK. So I would say the piece that's been the most lacking from my experience in the crypto module just got about 1,000 times better, because now you don't have to shell out to OpenSSL, and you don't have to rely on a third-party module that works with Node version 8.6, but doesn't work with Node version 8.9 or 10.2.
So this is in Node 11, you said, a lot of this stuff.
Yeah, most of this has landed in Node 11. And there's one more that's landed that has been had warning flags for a very long time, but finally had them removed, which some of you may remember Node's Speedy module. Did either of you use that?
No, I didn't.
Nope, not me.
So it was a third-party module to implement HTTP2, because HTTP2 used to be called Speedy, SPDY, which had some sort of acronym or meaning or whatever. And it was just a Google experiment. It was called Speedy. And then for a long time, people continued to call it Speedy, even though its new name was HTTP2. It's a very rare case, I think, because unlike SSL, where it was already around for a decade before the new standard came out and the name changed, with Speedy, it was only around for a couple of years before it got standardized. So people have adopted the terminology of HTTP, that word too, pretty well. It turned out that eventually Speedy became unmaintained and you couldn't use it. And I noticed that. I was one of the people that felt that pain a little bit. It's always rough when you go to update something and find out that it was more difficult than you intended. But, these things need maintainership, and people don't have, without sponsorship, open source can't survive. And so Speedy died, but HTTP2 landed officially in Node and is now stable and usable and has a backwards compatibility API. I haven't tried it out yet. I was just about to do this yesterday, because as part of this refactoring process, I came across some of my old Speedy code that was commented out. And I was like, I wonder how that HTTP2 module is doing. So it's landed, it's stable, it has a backwards compatibility API. It should work with Express. And that's what I'm going to test later today, is see if a basic Express app will work. And I expect that it will, because the HTTP2 API, the compatibility mode, basically gives you a standard HTTP server that shouldn't differ from the HTTP server APIs. You don't get all of the advantages of HTTP2, but then again, you never get all the advantages of HTTP2, because to implement it is really complicated and no one does it. Like, it's basically meant for the big boys that can do heuristic-based web servers or take advantages of incredibly niche features in a very, very special way. The non-compatibility API is not something that you would find enjoyable to use, most likely.
Yeah, well, I mean, that makes sense to some degree, just in the sense that if it's trivial to put in, right? So you have an HTTP server that does all of the HTTP2 stuff, you just kind of turn it all on. But if it doesn't, then yeah, you're really just going to care about the features that make the biggest difference for you as far as critical performance or critical scaling or things like that. And yeah, when you talk about the big boys, they have those problems. And so, being able to serve up, another 100,000 requests on their server is real money because it scales across so much stuff. Whereas, for me, for my website that gets, a few thousand hits per day, it's just not, it doesn't matter as much as long as it's fast enough and can keep up.
Yeah. And so despite all the hype that there was originally around Speedy and HTTP2, I've seen almost no one take advantage of its full spec of features or even close to its full spec of features. Most people just run whatever server they're running, whether it's Node or something else, they're just running it in a compatibility mode that gives them the advantages of the lower latency encryption, the compression, and potentially some of the behind the scenes session management that they're not necessarily aware of. Because you'll notice if you do visit sites that have HTTP2 enabled servers, if you look at your network tab, you'll see that the way the header response sequence goes is different. So HTTP2 actually has like context compressed headers. I mean, like typically compression is generic. Like you don't know the dictionary ahead of time that you're going to use to compress with. So you look at the data for a certain amount, and this is where like gzip does a great job, and Brotli does a pretty darn good job, and things like LZMA do an excellent job, but LZMA will read like a gigabyte into memory to discover the dictionary, so it'll take it an hour to compress your file. I mean, that's hyperbole, but not necessarily hyperbole, actually. Gzip will look in something like 32 or 64 kilobytes into your file to start discovering the dictionary. So compression works by this: analyze the data, create a dictionary, and then compress things into the dictionary that you find. So if you're looking at the English language, you could compress all of the common words, the, they, he, she, him, into a very finite space. And you could even compress words that are likely to happen in sequence in a particular bit of text, like his country, her skills, etc. You could just compress those into a single dictionary item as well. So with HTTP2, one of the things that they've done is, well, we know what all the common headers are. There's only a list of let's be really generous and say 100 different headers that you're possibly ever going to use in a typical HTTP connection. And so they actually just created the dictionary of those as part of the spec. So headers all get compressed away maximum efficiently because it's known ahead of time what every possible header will ever be. So the compressor doesn't have to think on the fly.
Right.
It doesn't have to make a dictionary miss error where, like, this happens in PNG images all the time, where if you create a PNG image that's 32 pixels wide versus 48 pixels wide, the one that's 32 pixels wide is going to compress better simply because the compression works in multiples of 32. So if you even expanded your image out to 64 pixels, you would get better compression than if you had it at 48 pixels. And don't quote me on that exact number, but I believe it's a 32 pixel boundary. It might be a 32 byte boundary. I don't remember exactly what it is, but it's something like that where, compression can fail really hard in cases that normally you would think it would do super well, based on dictionary misses where the next item that would go into the dictionary is just out of bounds of the memory allocation for the compression algorithm.
Well, it's too late, AJ. I already posted on Twitter that you said 32, so.
Yep.
The point is that it's something in that ballpark. It's specific to byte boundaries.
No, that makes perfect sense. I mean, I go back to studying network stuff where you're talking about calculating your network addresses with binary. And so that makes perfect sense, even though they're totally different things. But to me, it makes sense in my head somewhere.
Oh, yeah. Calculating network addresses with binary is good fun. I recommend anybody look up online for a bitmask tool, like IPv4 bitmask tool. You can start to understand that internet routers actually function very similarly to a music box, which also happens to function very similarly to a telephone switch. The bits on the wire kind of fall into place and cause a reaction to occur in a gate. So that's fun stuff to look up for those of you that are into that.
This episode is sponsored by Sentry.io. Recently, I came across a great tool for tracking and monitoring problems in my apps. Then I asked them if they wanted to sponsor the show and allow me to share my experience with you. Sentry provides a terrific interface for keeping track of what's going on with my app. It also tracks releases so I can tell if what I deployed makes things better or worse. They give you full stack traces and as much information as possible about the situation when the error occurred to help you track down the errors. Plus, one thing I love, you can customize the context provided by Sentry. So, if you're looking for specific information about the request, you can provide it. It automatically scrubs passwords and secure information, and you can customize the scrubbing as well. Finally, it has a user feedback system built in that you can use to get information from your users. Oh, and I also love that they support open source to the point where they actually open sourced Sentry if you want to self-host it. Use the code devchat at sentry.io to get 2 months free on Sentry's small plan. That's code devchat at sentry.io.
So let's go back to basics for a minute. As a front-end guy or even as, former Drupal, my familiarity with certificates is that, okay, you want to have HTTPS, so you go buy a certificate from GoDaddy or, wherever, and now you can use Let's Encrypt, and you install it on your server, and that allows you to have HTTPS. Can you explain what exactly is a certificate and what it's representing? If I remember right, you're basically representing, I'm a real person, I'm a real business, and somebody's basically vouching for my authenticity. Is that correct?
Yes. So we're going to get real basic for a second.
Good. Because I'm willing to bet that if I'm not the only one having this question. So,
all right.
All you experienced people, you can pretend you already knew this.
A certificate has on it a subject, which is a field that contains things like common name, which in the case of HTTPS is the server name or the host name, which is actually pedantically different from domain name in a couple of edge cases. So just important to note that host name is not 100% equivalent to domain name, just as an FYI. Weird edge cases that you'll run into if you ever work in DNS stuff. So it'll have subject and it'll have CN and it'll have example.com. And then it will have subject alternative names, SAN, sometimes just called sub-alt or alt names, depending on what reference you're looking at. And that will have the list of other domains that are valid on that certificate. And the actual text of them, they're prefixed with DNS : and then the name, because these certificates, they're called X509 certificates, and that's a schema. X509 is a collection of schemas or data definitions. So they're used for things other than HTTPS. TLS is used for mail. It's used for lots of application-specific protocols. I mean, mostly, it's usually generally wisest just to throw everything into HTTPS these days because the specs are so well done, the clients are so well done, you get great optimization. If you start to build your own protocol for some sort of niche network thing, you're probably going to end up getting worse performance than if you use HTTP, just because everything's so good these days that the inefficiencies don't outweigh the efficiencies. But on the certificate, you've got that information. You also have included in there the name of the authority that issued the certificate. And so this is when we say certificate chain, we're basically looking for this authority signed this certificate. And if I go up, what authority signed that certificate? And if I go up, what authority signed that certificate? At the root certificate level is a self-signed certificate. Pro tip for anybody ever dealing with self-signed certificates, don't use a self-signed certificate. Use a self-signed certificate to sign another certificate, and you'll actually have better compatibility with the whatever weird thing you're doing that you need a self-signed certificate for, just as an FYI. So the certificate chain is just looking at the issuer of the certificate, and typically the subject of the certificate is going at the lowest level down at HTTP is got to be what's on the URL bar, otherwise you get the red warning screen. But as you look at the certificate chain, the subjects become business addresses or business names and addresses and organizations and contact information and stuff like that, because there's domain validation, organization validation, and extended validation. So DV, OV, and EV certificates. When we talk about Let's Encrypt, those are DV certificates. As far as encryption goes, they're exactly the same as EV certificates. EV certificates just cost $1,000 more. That's all politics. It's
and that's because why? Because somebody's having to vouch for, because there's more risk because it's a larger enterprise. Why?
Paying to borrow someone else's reputation.
Yeah, that's sort of what I was.
So VeriSign actually had some discipline recently because of poor practices in security. VeriSign is basically, they basically print money. That's what they do. So they got in the early days of the .com, and now they just print money. And I don't know if they got kicked out of the root authority group permanently because of what they did, but I know that they were revoked for at least some time. And they were the most expensive. And literally, you were paying for your certificate to have the VeriSign name in the issuer bar. That's the main thing you're paying for. You're also paying about $25 worth of costs for a clerk to call you up, verify the phone number that you have listed in your business entity document, to go on the government website, to check out your business details, and to send you a letter with a code that you need to respond to that verifies that your business address is correct. So the extended validation for anything that you want to be verified on the certificate, they simply make a manual effort of doing some sort of confirmation. That's what you're paying for when you pay $1,000 for an extended validation certificate, is they're hiring someone at $12 an hour to spend 30 minutes or so Googling you and giving you a phone call and sending you a letter in the mail.
That's good, because I know that we could never fake addresses or phone numbers or any information like that.
No, never.
It used to be that when you went to a bank website, because banks, they've got big money, and banks typically would have like the secured by VeriSign symbol down in the bottom, especially in the 90s. And then you might remember there would be a big green bar, like a big bold green bar that said like Wells Fargo, or one case where it stood out a lot was MacSales.com, which is actually the name of the business is Otherworld Computing, but their website is MacSales.com. So you get this big green bold thing that would say Otherworld Computing, LLC, or Corp, or Inc., or whatever it was, and then MacSales.com. So because of what you just said, Google, or at least I believe that's one of the reasons they stopped doing it. But Google in Firefox stopped showing extended validation certificates. They did an experiment with it for a little bit to, kind of A/B testing, like some users would get it, some users wouldn't get it, to determine if it had like a negative effect on user experience or whatever. And at some point, they determined that it was better just to turn it off. And this helps in two ways. One, people are less likely to get conned into paying $1,000 for an SSL certificate that don't need it. There are instances like with government organizations or with certain niche use cases where you do actually want the benefit of having phone calls and validation of driver's license, business license, stuff like that happens when you pay that $1,000. But for a web dev, you have no benefit in that. So it helps prevent people from getting scammed by companies like VeriSign, and it also reduces the incorrect belief that that site is somehow more secure, because the encryption is exactly the same. The certificate just has a bunch of names on it. And when the encryption happens, the encryption is based on the web server you use, not the certificate you have. So if I have an up-to-date web server and an up-to-date browser, the encryption is going to be stronger, and it has nothing to do with the certificate, because the certificate doesn't specify what type of encryption I'm going to use. It does have a public key listed in it. And that public key is going to be used as part of that handshake, but it's not actually what gets used for the encryption. It's more for identity validation, because the encryption actually happens through a Diffie-Hellman key exchange, which doesn't require any certificate at all. It's, again, I'd recommend watching the Khan Academy video on that. They have an excellent explanation, one based on math, one based on mixing colors together. And I find them to be really dumbed down and intuitive. Despite knowing a lot of this stuff and having worked in this space, I'm not really an expert at the math. And so I find some of the dumbed down explanations have actually helped me a lot. And like I said, Khan Academy is great for that. What actually happens is there's a Diffie-Hellman key exchange. Usually it's the Diffie-Hellman style of exchange that's used. And then after that, you have an AES key that is one of like 3 AES standards. And there's GCM is the latest. It's also perhaps slightly less efficient. It actually has a checksum, because encryption and hashing, people often confuse them. Hashing can be used to verify integrity of data. Encryption can be used either as signing to verify identity or to keep data owned privately to the parties that are part of the connection. The encryption does not actually guarantee that the data is the original data. It just makes it highly likely. However, if you have an encrypted stream, if you get lucky, it's not like astronomically improbable that for this to happen. Like, you can use an incorrect key to decrypt encrypted data. Not every incorrect key will work, but many incorrect keys will decrypt data. They'll just decrypt it into encrypted data again, not to the original data. As in, they won't decrypt it, but the algorithm won't fail. Likewise, you can take an encrypted stream and you can change some of the bits in the stream. You have no idea what you're changing, but it's possible that a bit becomes corrupted in transfer, and that where that bit happens to fall when it decrypts, it still decrypts correctly. So GCM addresses this by saying, okay, for every block, there's going to be a checksum. So it does block, checksum, block, checksum, block, checksum, block, checksum. And if you look at the security tab in the developer tools in your browser, you'll see most likely that most websites you're connecting to are connecting or transmitting through AES GCM. And then another one is there's AES CTR and CBR. And the benefits of those are that they are slightly faster, take up slightly fewer bytes. And I don't remember, one of them is parallelizable. The other one, I think, still requires things to go serial. GCM requires things to be serial. So AES has a couple of different variants on it with different trade-offs. That's kind of how that bit works. The encryption is all based on the browser and the server and has nothing to do with the certificate. The certificate is only used to verify the identity of the connection. And all of this stuff is stored in a format that's called ASN1. It's basically the 1980s version of XML. So you could think of it almost like JSON, except it's more like XML. But imagine how bad XML is compared to JSON, and multiply that by binary, and that's what you get with ASN1. It's actually super simple to parse, though. I mean, if you were to consider parsing XML versus parsing ASN1, ASN1 is ridiculously easy to parse. Like for Greenlock, over the period of time, because of like different issues with this dependency or that dependency, or needing support this feature or supporting that feature, I've actually rewritten the entire thing. I'm only using native Node APIs, native web APIs, and code that I've handwritten myself. Once you understand ASN1, which it's difficult to understand because it's in binary and there's a couple little weird bits you have to twiddle, but once you understand it, it's incredibly easy to parse correctly and to pack correctly, and you can do it in very little code. So when you see these libraries like ASN1JS and PKI.js that are based on before we had any support in browsers or Node for good crypto, their ASN1 parsing libraries are like 100 kilobytes. And you don't need that. They incorporate all the X509 schemas as well. But if you just want to parse ASN1, it's incredibly simple. So if you have a small niche use case where all you need to support is, all I need to worry about is public keys, private keys, and certificates, you don't have to build out the entire crypto suite of X509 in order to do that. The formats, despite the fact that they're binary, which is what makes them complicated, are very, very simple. When you parse a certificate, it's just an array of arrays. That's all it is. It's an array that has like a name, a type, a length, a potentially context-specific identifier, and then a value, which is most likely, again, an array. There's like 10 arrays to one value. Like everything's deeply nested. So when you want to find a value, you have to go very, very deep to get it, but it's actually a very simple format.
Ooh, coming from PHP, that's easy. PHP deals with lots of arrays, or at least the Drupal world did, just because PHP handled them so well.
Yeah, it's really interesting and a lot of stuff that I want to dive into more, but we're actually getting toward the end of our time. So it's always interesting to me. We have the conversation and it's, well, can we do a whole episode on that? No, I don't know if there's enough there. And then, yep, turns out there was plenty there. So
Cool.
Just turn AJ loose on crypto and watch him go.
Well, my goal is to create a home server, right? I want something that can go in anyone's home, and that personally, I want my grandpa doesn't use the computer. My mom, my stepdad and dad don't really use the computer. And my sister, my brother doesn't really use the computer. Basically, the people in my family that care about connecting and sharing are the women and me. Like, I want something that people like the people I know in my family could use. And they're not going to be able to figure out how to buy an SSL certificate. And I wouldn't want them to be vulnerable to, some sort of attack. And I don't want things to have to run through like centralserver.com. What I want people to see in their browser with this server is john.smithfamily.com or something like that, where when people share, when they're talking over the phone, when they're sending an email, whatever, when they go to share something share content that they care about with people that they trust, that the communication is intuitive. And so, although I've not made as much progress on the actual end user experience of the applications that I want to make, I'm very, very proud of the advances that I've made in getting it to be simple for a person on a home network environment, which is a very hostile and terrible environment, to be able to simply connect to another person with a name that they understand and with encryption and security features that I know are top notch. So I've always been interested in weird stuff. Getting this deep into encryption has been because I want to one day see a box in people's homes that helps them share and connect, where they don't have to be security experts. Like, I'm learning it so that you don't have to. And in the interim, because of the content that I've generated and stuff, I also end up working with enterprise on-prem and IoT, because it turns out that they have the exact same needs that the average Joe in a home does, more or less.
Makes sense. AJ, there for grandmas everywhere.
That's what I hope to be my slogan one day, yeah?
Yep, there we go.
And if grandpas would get online, I'd be happy to help them too.
Yep. Yeah, funny enough, in my family, it was my dad. That was always the connector. And yeah. When I first started taking computer science classes in college, I thought programming was just a joke. In fact, I changed my major over to engineering and started doing computer engineering and chip design. Then I found Ruby and I fell in love. I love Ruby. It was my first real programming language where I dove deep and really learned how to make software that makes a difference for other people. Since then, and the way that we got started with devchat.tv, we started a show called Ruby Rogues. It's currently in the 400s of episodes. We've talked to hundreds of people in the Ruby community, about the Ruby programming language, about Rails, and about what makes good programming. So if you're interested in Ruby Rogues, or you just want to hear a long series of experienced programmers talking about real problems, then go check out rubyrogues.com. Anyway, let's go ahead and do some picks. Steve, do you have some picks for us?
Yeah, I'm going to go sort of old school on one today. One of the things I like to do in the pursuit of eating healthy is I make my own bread. Usually it's just straight whole wheat, but I use it for sandwiches and stuff. And it's really, really good, really, really easy to make. And so what I'm going to pick is the machine that I use. So I'm not so old school that I, hand knead it and roll it and do all that stuff.
Oh, come on.
I'm wimpy, but I'm efficient. So I use a Panasonic bread machine. It's the Panasonic SD YD250. And I'll put a link in the chat. But it's awesome. I can come in, like I've got a loaf going right now. I will come in, takes me about 5 minutes to put everything together, hit the button. 5 hours later, I've got fresh bread coming out. So it's really good. It's really healthy. I think there's like 7 or 8 ingredients total in a loaf. But you can also do all kinds of fancy stuff, like, you can make pizza crust or sourdough bread, or there's a whole recipe book that comes with the machines for all the different kinds of breads you can make. I haven't really explored the options, but for what I use it for, it's awesome. That machine itself is a rock. I've had it for years and it's still going great.
Nice. AJ, do you have some picks?
Yeah. So first, I'm going to pick this new version of Greenlock V3. If you've looked at Greenlock in the past and thought about using it, now is the time to come take a look again. I've reduced the API by a whole bunch. I've removed lots of backwards compatibility. This V3 is pretty much a rewrite. There's a few bits of code from the original thing that I've ported over, And most of the lower level stuff remains intact because that had already been rewritten over time here and there as different issues with dependencies and whatnot came up. But the whole thing is very small, whether you're using it in Node or the browser version will be ready soon. It's nearly identical code base. There's just a couple things I need to twiddle first. It's at the point where if you know how to use Express, you can use Greenlock. You don't have to know any of the complex stuff that I was talking about. I enjoy talking about it, but like I said, the reason that I am learning it is so that you don't have to. So if you want Let's Encrypt for local development, for IoT, for on-prem, for web hosting, basically whatever it is, I feel like you'll have your needs met with Greenlock. So please come check it out. And I'm also going to pick, if you want the benefits of the latest like $8,000 Mac at a fraction of the price, you could go buy, and by a fraction, I mean like a quarter or less of the price. You could go to the Samsung Evo 4 terabyte and get a nice 4 terabyte drive that actually has enough storage on there for you to fit something like a music library or a couple of movies, unlike the standard drives that Macs ship with these days. And you could pair that with a 2012 MacBook Pro. Check this out. You get a MagSafe power adapter, so easily just
I remember those.
Goes on, no worry about breakage. It has an Ethernet cable for when you need internet that isn't finicky and that works well, fast. It's got a Thunderbolt port so that you can connect in an extra monitor and then connect another extra Thunderbolt monitor to that if you'd like. It has, nobody needs FireWire, USB.
I love it.
It's got an SD reader.
It's true.
But here's the funny thing about the SD reader. I've tested this. I've had weird experiences. I finally narrowed it down. The SD reader seems to work with SD cards to write them, and it works with SDXC cards to read them. But it does not seem to be able to write XDSC. You need an external for that. I just figured that out as I was doing the GameCube modding stuff and having like these small cards work in it, but then slightly, 8 gigabyte card wouldn't work, but a 1 gigabyte card would. And I think that's the conclusion I've drawn. It's got nice audio out, so you can use like nice headphones with it. You can plug an amp into it. And also you get a DVD drive that if you're willing to pay another $200, you can upgrade to a Blu-ray drive. And if you want it to be lighter weight, you can just take the drive out. So big fan of the MacBook 2012 and very pleased that, I've got, other than that it only has 16 gigs of RAM, which has been more than standard for 10 years on Mac. It doesn't support 32 like the newest MacBook does. So if you're willing to pay the $7,000 because you need the 32 gigs of RAM, you got to go with that. And then last thing that I'll pick is, so there's this thing called healthcare ministries. There's 3 big ones. There's Samaritan, Christian Healthcare Ministry, and Medishare. And if you are a contractor and you proclaim Bible-based faith, then you can join these sharing ministries. And because it is a faith-based program, it counts for government concerns. Like my wife is still going through the green card process. She has to have insurance. I'm doing contract work. I don't want to pay thousands of dollars per month for insurance. And these qualify even for her, which is awesome. The way that they basically work is instead of being like insurance, because they're not insurance, although they qualify for most of the government requirements of insurances, they each have different semantics on how they work, but you basically pay into a shared bank account. And then when you have a medical bill, you send in the medical bill, and then you get reimbursed for it. And based on, you kind of have a sense of a deductible, like you pay more if you want a lower deductible, and you pay less if you want a higher deductible. But the terminology is different because it's not literally insurance. It's literally a group of people that trust each other and believe that in caring for one another's needs financially when you're in times of burden, they pretty much each of them have like a biblical scripture on the front that says something to that effect on like their website or whatever. One of them, Samaritan, has some kind of, I feel, unfortunate regulations in that you have to believe in the Bible in a certain way. So I'm not sure if like Catholics would qualify or not. I know some denominations they reject because you have to believe in the Bible in the way that they believe in the Bible to qualify for their program. And Christian Healthcare Ministries is the one that I joined, and they just kind of seem to be the most well-rounded. So I'm paying less than $300 a month for the 3 people in my family, my wife and our daughter. And we haven't had to use anything yet because you pay your normal doctor visits out of pocket. But I have a friend who had them as well, and they paid for their like $10,000 of baby expenses for delivery and any complications and all that for through Christian Healthcare Ministry. So,
are there any upper limits set?
There are, and it's going to be outlined on their website and whatnot. So Christian Healthcare Ministries has 2 programs. It has like their normal program that I think goes up to around $100,000 per incident, I want to say. But then they also have another program called Brothers Keeper, which is kind of like the catastrophic plan. And then they also have this third program called the Prayer Page, which is basically they publish every month, like, here's people that have needs that have made their needs public. And here's the deficit that isn't going to be covered this month. And they give you the opportunity to donate more because it's donation. It's required in order to get the benefits. You can't join without donating the minimum donation, but it is a gift and you get the benefits of sharing if you meet the gift. But, you're talking like, you get $10 or $15 more during a month of higher need, and it covers more people's costs. And those people just stay on the prayer list until their needs are covered. And Dave Ramsey talks about it too.
Yeah, I have some friends that are on Medishare. I've talked to them. So yeah, as I understood it was like out of pocket and then you get reimbursed.
Yeah.
Instead of like them direct billing the plan or something like that.
Yeah, my brother-in-law is on it as well. And they've definitely talked about some of the pros and cons. But yeah, if, depending on your situation, it may be a cost-effective way to get help with your healthcare. So
yeah.
AJ, is that something you can do just like for a specific term? Like I need coverage for like 2 months or something like that? Or is it like a long-term commitment that you have to make?
I'm not entirely sure. You can actually call up and talk with people. Like they basically say, here are our general policies. And they say, if you feel like you don't fit into our general policies, give us a call. So it is a faith-based program. They want to help, they want to help people that are that meet the government requirements according to their regulation and stuff, that you have a similar enough faith that you participate, and they want to help people, and they have things that they can be lenient on. But typically you have to live a Bible-based lifestyle, and you have to basically, I think that means like you don't drink or smoke and you attend church occasionally or have some sort of religious participation that's Bible-based. And then there is some sort of requirement for the length of time, but it's going to vary from one to the other.
Yeah, I think your best bet is just to go and jump on a call with somebody over there and figure it out. I'm going to throw out some picks. By the way, AJ, my MacBook will do everything yours does as long as you can connect it with a USB-C. So. Oh,
yeah, I've seen those plates that you put underneath it to give it battery power and be able to connect things. Those are awesome. I love it when it extends out like an extra 4 inches from the side of the MacBook particularly. That's just great. Yeah, I'm looking forward to that.
Yeah, and I've never actually dropped my laptop off table or bed that it was on with one of those plugged into it and have it, bust stuff and
break off inside of there. So you got to try to get it out with tweezers.
It didn't break off inside of there, but it did cause some problems. So, I mean, it would have if that had ever happened to me. So for me, for picks, yeah, I really miss the old MacBooks. In fact, my next MacBook is probably going to be made by HP or somebody, a Lenovo. So I've got a couple of picks here that I'm going to throw out as well. I got these Velcro straps for my desk, and I bought them on Amazon, and I was like, oh, well, I'll get a few. And I wound up getting a pack of like 100 of them or something. I don't need that many, but it's been really nice for me organizing my desk. So I've got a couple of monitor arms that hold the monitors up so that I can work off of things. I'm really happy with them because it just gets the cords out of the way. One less cluttered thing on my desk. So I'm going to pick that. The other thing that I'm going to throw out, kind of in the vein of AJ's pick, is, and I'll try and find the article, but I think it's on Lifehacker. But apparently there are upgrade kits for the big cheese grater Mac Pros that make them compatible with the latest version of Mac OS. That's something that I'm looking at doing because I have one of those sitting under my desk, and you can upgrade it to a certain point, but you can't upgrade it to the most recent version. And it'd be nice to have a powerful machine sitting under my desk again, and then I can just use the laptop when I need to be out and about. But my laptop is so much more powerful and it's more up to date than the cheese grater Mac that I can't, I use it as my primary machine. And then, I'm limited on the hard drive space, and I'm limited on some of the other capabilities that I have. And I would prefer to just be able to come sit down and do whatever I'm doing here. And then when I am traveling, just have the laptop as kind of a nice way of getting work done when I'm not able to sit down at my desk. So anyway, I'll see if I can get that link in the show notes. Then AJ, do you have any other recommendations for resources if people want to learn more about cryptography or security or things like that?
So in general security, there's a thing called the OWASP list. And that basically goes over the things you hear every day, like SQL injection, form validation, that type of stuff. I have found a variety of educational videos, but I think that the Khan Academy set was the most cohesive, where I watched it from beginning to end. At the end, I was like, okay, cool. Like, even though this isn't the type of stuff you need to understand for security, because typically you don't implement these crypto algorithms, you certainly shouldn't create new algorithms, but it's nice to know how they work conceptually to kind of build your mental model around like how to use them and why they're secure and when one is the right tool for the job versus the other. So when I say like I've built all this stuff for Greenlock, the native stuff, the actual encryption I left to now completely in core node and core web crypto. But the other bits and pieces are what I have rewritten, the things that are just like the packing and parsing formatting stuff. There are a number of tools out there that kind of help you explore some of these related technologies. JWT.io is a cool one for JWTs. If you just Google JavaScript ASN1 parser, there is a more formal parser that is great for debugging. That is what I use to help me understand better as I was building mine. Like I said, mine parses just into an array of arrays, and then I have very limited code around packing and parsing the schema, because either it's going to be exactly correct or it isn't. So I don't need to handle like the hundreds of cases. But that was a tool that if you need to do something with that, I'd highly recommend. And there's some other tools I found similar to that in the past when needing to look at like how to pack and parse binary data. And then I think just developing an interest in it, talking about it, do a presentation on something that you're not good enough to do a presentation on. And then afterwards, you'll have somebody that knows better than you say, hey, I thought that was cool. You did a really good job on this. Have you heard about this thing yet? And so you just kind of, like with everything else that you want to learn about, just by sharing the expertise that you have, remember the 0 to 1 philosophy. If you know one piece of information, you're above 0. You're now expert in comparison to 99.9% of the population. So just in sharing the little bits that you learn, you're going to attract other people that are more expert than you, as well as people that are interested in what you're interested in that are going to share things with you as well. So it's just ironic, I don't know if that's the right word, but sharing what you have learned is probably one of the best ways to learn because it connects you.
Well, obviously, from my experience, one of the maxims that I always like to use is that if you want to learn something, teach it.
Yep.
If you got to teach it and you have to pass on knowledge to other people, then you really need to know it yourself. And so that causes you to learn something really well. And so even if you don't know it, it could be something really basic, like say how certificates work, put together a class on it, teach it to somebody else. And that way you're going to learn it so much better yourself.
I'll also link to my blog. These are not necessarily the best articles in the world, but they're what I refer to myself. Like I try to make a habit of everything I learn. I try to publish. And whenever I don't, I always get mad at myself because there's never a time that I've learned something that I didn't need to know it again, like 6 weeks or 6 months later. And so I've got stuff that I've had to learn about big ints, about crypto, about HTTPS, about Let's Encrypt. So some of the stuff, if you go back to like 2015 and find an article back then, it may not be 100% accurate up to what's available today. Like if there's a shim for something, like if I mentioned in an article, oh, you can't do this in Node, you have to use this. Well, you might actually find later on in like 2018, I might have a very similar article. And then I'm like, hey, now you can do this in Node. So if you just search through my blog for topics related to BigInts, RSA, ECDSA, OpenSSH, OpenSSL, ASN1, X509, blah, 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 you will probably find something in your area of interest that will help you jump your understanding from 0 to 1.
Cool. All right. Well, let's go ahead and wrap this one up. Thanks for coming, guys.
Oh, no, it's a lot of fun. AJ's got a lot of knowledge that it's good to hear.
Yep. Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CACHEFLY.com to learn more.